Hello student, welcome back to the one more session of microcontroller and embedded system. Today I am going to start the module 5, that is RTOS and IDE for embedded system design. So in this session we will be going to discuss more on operating systems basics. Then in the succeeding session we will discuss on RTOS, that is real-time operating system, and integrated drive environment IDE for embedded system design. So in the previous session we studied different types of approach for the design of embedded firmware. There are two approaches. One is called as super loop based approach. It is also called as a conventional procedural oriented approach. Second approach is something based on operating system based approach. So the super loop approach, this one is used when the time constraint is not important. Super loop approach are used in application or used in the design of embedded firmware where time constraint is not important. That is the task execution in non-real time. But certain application like mission critical application demands for time critical response, or in such application delay in the response may be catastrophic. For example, you consider flight control system or anti-lock brake system in automatic engines, nuclear monitoring device where time response is very important. Such systems are designed based on operating system approach. So we have two approach. One is a super loop approach, second one is a operating system based approach. Now if you design embedded system in time critical response for task, then certain events or tasks are addressed by the following way, that is assigning priority to the different task and executing highest priority task first. That is the one thing. Second thing is, instead of sticking the priority by manually, dynamically change the priority of the task based on the need. That is the second one. Third one is introduction of operating system firmware based firmware rather than going for super loop based approach, going for operating system based firmware execution in the embedded device. So all the three types of method we use, like assigning priority to the task, then dynamically assigning the priority, then go for operating system based approach. Now here we will see now the different concept related to the operating system basics. We know a operating system is a mediator between the hardware and the user. Like it acts like a bridge between user application, that is task, and underlying system resource through set of functionalities and service. So the primary function of the operating system is, like any operating system should be convenient to use for the user, and it should organize and manage system resource efficiently and correctly. System resource in the sense like memory, then input output, then storage. All these system resources should be managed efficiently and correctly. So these are the basic things we need to understand in the design of operating system. Now this is the inside view of the basic components of the operating system. So you can see operating system is like abstract layer between underlying hardware and the user application. So this diagram shows the various components of the operating system, like user application. The various component of the operating system lies between underlying hardware and the user application. So the components are IO system management, file system management, time management, process management, and memory management. All these are a part of these are the different services provided by the kernel. We'll see what is a kernel actually. Kernel is a core part of the operating system where most basic services are given. It is a core part of the operating system where most basic services are given, like IO system management. So what is IO? So all these different types of services we will see in the later part of this session in detail, but for the time being, IO system management includes how to get the input from the external world and how to process this input and how to provide that to the output device. Then file system management deals with how to manage the files, different types of files and directory structures, etc. Time management is also one of the important aspect, because the kernel has to give equal chances to all the process. In that case, time management is very important. Process management. So what is a process management? A process is an active entity. It is loaded in the main memory, but file is a passive entity. Here in the process management, we are going to study how to managing the different process, like how to synchronize the process, etc. And memory management. So memory management is the one of the services provided by the kernel to allocate and deallocate memory to the different resources or different different process. So all these things we will study in detail as we proceed in this session. So now next one is kernel. What is a kernel now? Kernel is the core of the operating system. So it is responsible for managing system resource and communication among the hardware and other service. I told you kernel is a core part of the operating system. For operating system, kernel is like art. For operating system, kernel is art. So kernel acts as a abstraction layer between the system resource and the user application. Like it is a abstraction layer between the system resource and user application. We have seen system resource like underlying hardware and user application. It is abstraction layer. So kernel contains a set of libraries and services. What type of services it provides? Kernel provides different types of service, like as I told you, memory management, process management, time management, file management, and IO system management. These are different types of services provided by the kernel. We are going to study in detail. So first we'll see process management. Process management deals with the managing the process and task. So what and all things it will deal here, like it will like deals with setting up of memory for the process, setting up of memory, allocating memory for the different process. That is the job of the process management. Loading process code into the memory, then allocating system resources to the various processes, and scheduling and managing the execution of the process within the particular time, scheduling and managing the execution of the process within the particular time. All these are done by the process management. Other than that, we have something called as setting up and managing process control block. This one thing is important. What is PCB? This is process control block. Is a type of data structure. It is maintained by the process. When the CPU switches from one process to other process, so it will store the temporary data in this data structure, so that once it completes the particular process and return back to the original process, it can make use of that original data saved in the data structure, that is saved in PCB. So PCB is the process control block, is something like a data structure. It maintains certain information related to the process. Then we have something called as inter-process communication and synchronization. Inter-process communication means when there are multiple process runs, then each process will use different types of the resource. And here important thing is communication between the different process and synchronization between the different process is required in order to allocate the resource in a smoothly manner. So this is very important here, inter-process communication and synchronization. Other than that, when the process completes its task, then operating system, that process management component of the operating system will terminate that process, and that is called as process termination and deletion. Once the process is terminated, then the particular resource allocated to the process will be freed up and it will be released, and it will be later allocated to the different process. So this is something related to the process management. Now after that you will see now what is a primary memory management. So now we will see the primary memory management, that's the other function. So we are discussing here different types of services provided by the kernel. First one we studied now process management. Now we will move to the memory management. In the memory management, the first thing we have to see like primary memory management. Primary memory management refers to the volatile memory, that is the main memory, random access memory. We know the volatile memory, which is also known as random access memory, and it is known as volatile because whatever the content stored in this memory will be lost when the power is off. So the short abbreviation form for this one memory management is memory management unit. For this one is memory management unit, where the processes are loaded and variables are shared and stored. So what is the main job of this MMU unit? So the MMU unit is a part of the kernel and is responsible for keeping track of various part of the keeping track of the different part of the memory area, and it will keep the particular keep the track of the memory allocation to the different process. And what it will do is it will allocate and deallocate the memory space based on the requirement. If the particular process is terminated, then it will deallocate the memory from that process and it will allocate the memory to the different process. This will be done by memory management unit. So now we will proceed to the file system management. So what is the job of the file system management? We know file system is a collection of related information. A file could be a program, source code or executable code. So there are different types of files we know: text files, image files, Word documents, audio video files, etc. So what is the job of the file system? File system management is the important part of the kernel, important service provided by the kernel, and it is responsible for creation, deletion, alteration of the files. When you create any file, how the files are stored in the file system management. There are different types of file system managements are there, FAT16, FAT32, and NT file system, all those things. So the files are created, deleted, altered. All these should be kept track by the file system management. Then the creation, deletion, and alteration of the directories. So directory is a collection of files. This is also done by the file system management. Then saving of the files in the secondary storage memory like hard disk, providing automatic allocation of the file space based on the amount of free running space available. So providing the automatic allocation from the of file space based on the amount of free running space available, providing flexible naming convention for the files. All these are the task of file system management. Next one we will move to the IO management. This is one of the important service. So we know IO system is responsible for routing IO input output request coming from the different user application to the appropriate IO device of the system. So IO system management or IO device management. This is the one of the important service provided by the kernel, which will allocate IO device to communicate with the processor and with the operating system. So the main IO device is like a keyboard and a mouse. Other than that, input device is keyboard and mouse. Other than that, different types of input device, like you can use a gaming device, like a joystick gaming device, that is also input device. Other than that, output device is a standard monitor. So this IO system management kernel is responsible for routing IO request coming from the different user application to the appropriate device. So well-structured OS, direct access of IO device are not allowed. This can be done through only application programming interface. So kernel maintains the list of all the IO device of the system, and each device has got its own device driver. So this device drivers to be loaded in order to communicate with the particular device. So if you load the device driver only, then you can communicate with the particular device. So device manager of the kernel is responsible for maintaining, handling responsible for handling all these drivers. Like it is responsible for loading and unloading device drivers, exchanging informations and the system specific control signals and from the to and from this device. For those things are those things are the important task of a device manager. Then next one is we will move to the secondary storage device. So secondary storage management. Secondary storage managements are like hard disk. Then other than that we have CD-ROM, DVD, and something like backup medium like tape device, etc. All these are these are something called as secondary memory, because secondary memory is like non-volatile. We had discussed something like primary memory. Primary memory is volatile. So in most of the secondary system, like data are kept in permanently in a secondary device like hard disk. The secondary storage management tasks are like disk storage allocation, disk scheduling, free disk space management. So as the free disk how the space is managed, free disk space are managed depending on the different files, etc. Disk scheduling, disk storage allocation. So all these are the job of secondary storage management. Now the next one is the protection system. Like modern operating systems are designed to support multiple users. So when it supports multiple users, then different level of access permissions are permission should be given. So for this different level of access permission, the protection system is to provide different level of access permission. Protection system is very important, because you need to, when multiple users access, then there will be different process running, and you need to protect one process from the other process, so that one process cannot access the resource from the other process. For all these protection systems are required. This is the job of the protection systems. And next one is the interrupt handler. Kernel provides interrupt handler mechanism to interrupt the processor when there is a immediate attention of the processor is required for depending on the certain task. That will be done by the interrupt handler. Next one is kernel space. Now important services offered by the kernel and OS. Something called as kernel space and user space. Actually, kernel space is the memory region where kernel services program is kept, and user space is the memory region where the user program resides. Suppose if I am in the user space and executing certain user program, and if I make a system call to the system call that should be executed in the kernel space, then CPU switches from a user space to kernel space, and that is kernel space, and the execution will be protected, because now the CPU is running in the kernel space, and execution will be protected from unauthorized access by the user programs and application. So the memory space at which the kernel code is located is known as the kernel space, and the memory applications space where the user code is located is known as a user space. So the partitioning memory system into kernel and user space is purely operating system dependent. Most of the operating system keep the kernel application code in the main memory, and it is not swapped out into the secondary memory. Now we will see there are two types of kernels. One is called a monolithic kernel, second one is a microkernel. So we have here two approaches which is used for building kernel. One is called as monolithic kernel, and second one is a microkernel. So the name monolithic kernel actually indicates it is large in size, like it is heavier and bulkier, and all the services are built in. So monolithic kernel architecture, all the kernel service run in the kernel space. All kernel modules run within the same memory space under the single kernel thread. So what is the drawback? Drawback is any failure, any error or failure in any one of the kernel modules leads to the crashing of the entire kernel applications. This is the drawback of the monolithic kernel, because monolithic kernel is larger in kernel size and heavier because all the modules are built into that one. We have one more module that is called as a microkernel. So microkernel design is something like it makes the kernel very light. The name itself, micro, indicates size of the kernel is small. So the microkernel design incorporates only the essential service into the kernel. The rest of the non-essential services are implemented as a program known as servers. Now, what is the essential service? Essential service is like memory management, timer systems, interrupt handler. All these are essential service. Then, if you call what are the non-essential service, it is implemented as a servers. Then it is a web servers, Apache servers. All these are implemented as a part of the servers, not as the part of the microkernel. So, what are the benefits of the microkernel? The benefits of the microkernel are robustness. If the problem encountered in any of the service which runs as a server, that can be reconfigured and restarted without restarting the entire operating system. Hence, the corruption of the kernel services are ideally zero. Services are ideally zero. Second one is configurability. Any services which runs as a server like web server or Apache server can be changed without the need to restart the whole system. This makes the system dynamically reconfigurable. So these are the two benefits. One is the robustness, second one is the configurability. Now next we will move to the type of operating system. So in the type of operating system we will see what is the general purpose operating system and what is the real-time operating systems. So as I said, the type of operating systems are like a general purpose operating system and RTOS, that is real time operating systems. Now what is the difference between this one? Like the operating system which are deployed in general computing applications are called as general purpose operating system. For example, Windows 10, Windows 8.x, XP, MS-DOS, all these are examples for general purpose input output system. These are often quite non-deterministic in behavior. These are non-deterministic means without any it can perform non-deterministic task. There is no particular deterministic task. Whereas we have one more system, that is operating system, that is called as RTOS. It is a deterministic, shows the deterministic behavior, like it will perform fixed set of services in fixed time. That is called as a deterministic in timing behavior. So RTOS service consumes only known and expected amount of time regardless of number of services. So RTOS decides which application should be run, in which order, and how much time needs to be allocated for each application, etc. So example for RTOS are Windows Embedded Compact, then QNX, VxWorks. All these are different examples of RTOS. Next, real-time kernel. As we discussed, in a general purpose operating system has got kernel. Same in the similar way, embedded system or real-time operating system also got its own kernel, that is called as real-time kernel. It is a specialized, highly specialized, and it contains only minimal set of services. So these are the basic functions of the real-time kernel. As we already discussed all these functions earlier also, like task and process management, task and process scheduling, task and process synchronization, then error exception handling, and memory management, interrupt handling, time management. All these are different functions of a real-time kernel. So now we'll move to the one by one, that is task and process management. So what is a task and process management? So task and process management deals with the setting up memory space for loading task code into memory space. So as we studied in general purpose operating system kernel service, we studied PCB, process control block. Here it will set up something called as a task control block to to allocate the resource and to keep the track of memory space, resource and setting time, etc. All this done by using task control block. So task control block is used for holding the information corresponding to task. So then what is there in the task control block? Task control block contains the following set of information. One thing is a task ID, task identification number, task state like current state of the task, example ready state for task which is ready to execute. Then task type, like task type indicates what type of the task. The task can be hard or real time or soft real time or background task. These are the different types of the task. Then task priority, like priority the task. If the priority is 1, the task with the highest, task priority is equal to 1 for the task with priority 1. Task context pointer, like context pointer, each task has got pointer which will point to the next task, that is pointer for context saving. Then task memory pointer, pointers to the code memory, data memory, stack memory of the task. Task system resource pointers, like pointers to the system resource, mutex, semaphores used by the task, mutex, mutual exclusions. For all those things are called as mutex. Then task pointers to the other TCBs. One TCB will point to the other TCB. This is done by the task pointer. Task pointers and other parameters. All these are important information related to the task is loaded in TCB. The parameters and implementation of TCB is kernel dependent. So next one is the task process scheduling. Here it will deals with this how the CPU, like sharing the CPU among the various tasks and the process. For this it has got particular application called scheduler, which handles the task scheduling. The scheduler is an algorithm and algorithm implementation which performs efficient optimal scheduling of the task. And the task process synchronization deals with the synchronizing the concurrent access of the resource which is shared across the multiple tasks and the communication between the various tasks. So in the next session we will see error, exception handling and deadlock. What do you mean by deadlock? What do you mean by timeout? Then what is the memory management in real-time operating systems? Then how you handle interrupt in real-time operating systems? Then time management, time management. Then what do you mean by timetic? Then what is hard real time and soft real time? Then we'll see in the next session. Thank you for your cooperation. So hello students, welcome back. In this session we will continue the basics of the operating system. In the last session we studied different managements, different services offered by operating system or kernel of the operating system. So here we will see now in this session error or exceptional handling. Error or exceptional handling, this is one of the important service provided by the kernel, deals with how to handle error during the execution of the task. Like the errors or exceptions may arise because of insufficient memory or timeout or deadlock or deadline missing or bus error or divide by zero error are the examples of exceptions. So insufficient memory error or exception occurs when there is memory allocations are not sufficient for the particular process, like whatever the allocated memory is not sufficient to execute the particular process, then insufficient memory occurs. And deadlocks occurs when two or more processes, if each of them holding some resource and compete for getting other resources held by the other process, and in such state the process cannot execute, and system will be in the same situation without progress, is called as deadlock. So deadlock is the example. See, it is the example of for the kernel level exception. whereas timeout is the example for the task level exception. Deadlock is the example for the kernel level, where two or more processes are competing for the resource held by the other process. That is called as a deadlock. Then here the explanation for the deadlock is given. So deadlock is a situation where the set of processes are blocked because each process is holding a resource and waiting for the another resource acquired by some other process. Other than that, we have something called a timeout and retry are the two techniques used together. The task retries and event message certain number of times. So here timeout is a best example for exception at the task level. If the response is not received with the stipulated amount of time, then that particular process can be aborted by using timeout. Then memory management. So we have discussed memory management in general purpose operating system. So memory management function of an RTOS kernel is slightly different compared to general purpose operating system. RTOS achieves predictable timing and determines behavior by compromising the effectiveness of the memory allocations. So what RTOS memory management makes use? The RTOS memory management makes use of block based memory. So RTOS kernel uses blocks of fixed size of dynamic memory, and the block is allocated to the task on need bias compared to the general purpose operating system memory management. So most of the RTOS kernel allows tasks to access any of the memory blocks without any memory protection. We have studied protection in the case of general purpose operating system to protect the process when the multiple users are accessing the operating system. Then there is a need of process for the protection of the edge. There is a need of protection for protection for the different processes, so that one process will not access the resource allocated to the other process. But in RTOS, it will not adopt any type of memory protection to achieve predictable timing and avoid timing overheads. If we deploy memory protection, then it will become like the RTOS code will become heavier, and it may not provide a timing behavior. Actually, RTOS are designed to provide timely response. This is not possible if you adopt memory protection. So these memory protections are not there, but some commercial RTOS allows memory protection as an optional, and a kernel enters in that time, enters a fail-safe mode when illegal memory access occurs. Now one is the interrupt handling. Now we know interrupt occurs to draw the attention of the processor, deals with handling various interrupts. Interrupt handling deals with the handling various interrupts. Interrupt inform the processor that external device or an associated task requires immediate attention of the processor. So interrupt can be either synchronous or asynchronous. So synchronous interrupts, usually the software interrupts which occurs in sync with the currently executing task is known as synchronous interrupts. Like it is sync with the currently executing task, and it is normally implemented by using softwares, and here divide by zero, memory segmentation, all are the interrupts example for synchronous interrupts. For synchronous interrupts, the interrupt handler runs in the same context of interrupt task. So, but we have another interrupt that is called as asynchronous interrupts. There is an example for asynchronous interrupts are time overflow interrupts, serial data reception interrupts, transmission interrupts, etc. And for asynchronous interrupts, the interrupt handler usually returns a separate task, and it runs in the different context. Means in the asynchronous interrupt, there is it runs in the same context, but here the CPU needs to switch over from, for example, whenever interrupt is called, it needs to switch over from user space to kernel space context. Like here, the interrupts are handled in the separate context. So priority levels can be assigned to the each interrupts, interrupts, and each interrupts can be enabled or disabled individually. So next one is the time management. Time management is essential for providing time reference for all the applications in RTOS, and RTOS RTOS are designed for timely response. That's why time management is very important in RTOS. So time reference to kernel is provided by a high resolution time clock RTC, which is a hardware chip. So hardware timer is programmed to interrupt the processor control at fixed rate, and that timer interrupt is known as timer tick. And timer tick is taken as a reference by the kernel. Timer tick is interval may vary depending on the different types of the hardware. Timer tick varies in the microsecond range. The time parameters for the task are expressed as the multiples of the timer tick. These are the where we are using this timer tick references in the kernel and task execution. So now, for example, system time is updated based on the timer tick. System time register is a 32-bit register, and if you assume timer tick is 1 microsecond, then system register will reset in 2 raised to 1.19 hours. Every 1.19 hours, system time register will be reset. So it will be calculated by, we have system time register 32-bit register, and time tick is 1 microsecond, 10 to the power minus 6, divided by 24 hours, 60, 1 hour means 60 minutes and 60 seconds. This gives 1.19 hours. Suppose if you assume timer tick is 1 milliseconds, then you will get approximately 50 days. 50 days, this timer, within 50 days, this system timer will be updated in every 50 days. If you take it is a 1 millisecond timer tick, if you take it is 1 microsecond, then it will be updated every 1.9 hours. That system register will be reset every 1.9 hours. Now, timer tick interrupt can be utilized for the following action, like save the current context. When interrupts are running in different context, it has to be necessary to save the current context when there, because CPU may switch over from user space to the kernel space, user space context to the kernel space context. That time it is necessary to save the current context. Then increment the system time register by 1. Generate timing error and reset the timer register if the timer tick count is greater than maximum range available for the system register. Then update the timers implemented in the kernel, to update the timer, either to count up or count down. Activate periodic tasks which are in the idle state. For all these the timer ticks are implemented. Then other than that, invoke the scheduler, schedule the task, then delete all the terminated tasks and their associated data structures. For all this purpose, we are using timer tick. Next one is RealTime. A real-time operating system which strictly adheres to the timing constraints for the task referred by RealTime. Real-time systems are the systems which will provide the response, timely response, because any delay in the timely response leads to catastrophic. That's why our real-time systems are the systems which provide timely response. So in our real-time systems works on the following principle: late answer is a wrong answer. For example, you see some of the example like anti-lock brake system, airbag control systems. All these are the examples for the our real-time system where timely response is very important. Otherwise, you know the situation, what will be the situation. So here it works on the main principle, like a late answer is a wrong answer. But we have something called as a soft real time, where the timely response is not very essential. Real-time operating system that doesn't guarantee meeting deadlines but offer the best effort to meet the deadlines are the soft real-time systems. For example, you take the ATM machine. ATM machine is the example for soft real-time system, because it works on the principle like late answer is acceptable answer, but it could have done a bit faster. For example, you take the automatic teller machine. Normally automatic teller machines, once you insert your card into the ATM, within 30 seconds normally it dispenses the money. But if it take so if suppose if the ATM takes more than 30 seconds, like if it takes 1 or 2 minutes to dispense the money, then it's also okay. Oh, it's also okay. But compared to the actual situation, it is slower. So if it takes more than 30 seconds, it's okay. Nothing fatal happens. But it says like. It works on the principle like late answer is it works on the principle like late answer is an acceptable answer, but it could have done bit faster, whereas in hard real time late answer is a wrong answer. So this is the difference between hard real time and soft real time. With this we have completed basics of operating system with context to RTOS. Now we will proceed to the next one, that is a task, process and threads. This in the next session we will see what is a task, what is a process and what is a thread. Thank you for your cooperation.